Pre-calc lesson 25, number 11. It wants to find the domain and just the domain of the function defined by each equation. So you have to keep in mind that there's pretty much just two things that you can't have in your domain, and that's a zero denominator, and you can't have a negative even root. Usually I'll just say a negative square root, but really you couldn't have a negative fourth root. It's usually just going to be square roots in your book. Just look out for negative square roots. You can't have those. They're not real numbers. And remember that we don't divide by zero. Okay, so look at each function and decide whether there's some restriction on the domain. This is a square root function, and you might already know that square root functions, because there's something on the wall that I wrote, a little picture of the square root function. It looks kind of like that. So this one we're going to find out, well, we know that there's something that we can't have, right? We can't have our x values can't, whatever's inside here can't be zero. They can't be negative. Gosh, something happened to my brain for a second. I feel better now. No negative even roots. Okay, so let's go like this. 2x minus 1 has to not be negative. I think that's a good way of saying it's not negative. This inside part can't be negative, so it has to be positive. That's kind of what this says. It has to be greater than or equal. You can have a zero square root. The square root of 0 is 0. So solve this out. Add 1, add 1. Okay, so looks like x is going to equal a half. Well, x has to be greater than or equal to a half in order for this to have a positive, what's it called? A radicand, a positive radicand. So I already wrote kind of the little, how I'm going to do my answers. Domain is the set of numbers where x is a member of the real numbers such that I'm just going to say x is greater than or equal to 1/2. I think that's all I have to say. Let me check and make sure that's right. Number 11. Yep, that's all you have to say. Okay, so this one has two things going on. There's only two rules. There's a denominator rule and the root rule. Well, we have a denominator and a root. So how are we going to do that? What would make a zero denominator here? I think the only thing that would make a zero denominator here is x is 3, right? Because it would go 3 minus 3 is 0 squared. So we know that, I'll just write a little note to myself up here. X can't be 3. Okay, that's for the denominator rule. Okay, for the negative root rule, let's see what we can do here. We'll do the same thing we did on the last problem. X minus 3, or in other words, the radicand, has to be greater than or equal to 0. Well, it can't really be 0. Oh, hey, we can do both rules at once. No, we can't. It can't really be 0. This will go like that. And then we'll say x has to be greater than 3. It can't, so basically what we're saying is x can be greater than 3, it has to be greater than 3, or else we'll have a negative, but it can't be 3 because then we'll have a 0, so that one was kind of tricky. So there's two little exceptions that we have to write down. But really, if I write down this one, doesn't that already exclude this one? So I'm just going to write this one down, because if it's greater than 3, it doesn't have to be equal. If it's greater than 3, it can't be equal to 3. So we're just going to say x is greater than 3. That was a little, confused myself a little bit on that one. So this is how you could write that. Okay, and then the last one, well, the last one doesn't have, remember there's two rules. There's the denominator thing and there's the root thing. Well, you've got denominators going on over here. So what can x not be? Well, that can't be 0. So we know that x can't be 1, because if I put a 1 in there, that's what would make it 0. A negative 6 over here would make it 0. So the two things that x can't be are 1 and negative 6. They can be anything else. There's no other restrictions. Just you can't have a 0 denominator. So let's just go like this. I think we can use a comma. Let me check with the book and see if I can just use a comma for this notation. Yeah, you can just use a comma. And that's how your book has it. So that's okay for your notation.